Okay, well, we're back, and this is going to be a little bit of an intro to the circuit building part of Lab 1, just to kind of guide you through some of the important steps of setting up the board.
So we have our component kit out, so you might want to get that out. We have our breadboard and we have our multimeter set up. We also have out this little kit with the wires in it for connecting up the breadboard, and we've already plugged in one of our power supplies. So go ahead and get that set up. Find a good spot with a standard outlet so you can plug that in. And feel free to pause this video at any point if you want to catch up. In fact, what we've already done is started with a few wires on our breadboard connected. It may not be, we can actually zoom in a little bit here so you can see what's going on our board. And your colors may be different, so and the colors obviously of the wires don't matter, it's your configuration and orientation. You can see that we've already connected a few here that correspond with your lab. These are actually going to be the connections for our DC circuit here for our input, and these are just going to be the ones that we're connecting our resistors to.
Yeah, our power supply is going to come in here.
So what I'm going to do is we started this way just so you could kind of get a sense of where we're going, where we're coming from, so you don't get too lost if you're not sure what these components are doing. So this is our DC power jack. It's I believe it's called your barrel jack on your sheet. It's the one with 3 pins. If you can see that, I don't know if and it has on the inside, it has a little pin sticking up. So the 3.5 millimeter has the 5 pins. This is the one with the 3 pins. What we're going to do is we're going to go ahead on our, let me zoom back in, on our breadboard, the way we have it configured. And again, yours might be a little bit different, but so bear with me. The 2 pins here are going to be the ones that matter, the ones right that are in line with each other in the middle of the barrel jack. The one on the far side that does not have the hole in it, that's actually going to be your positive. The one in the middle here is going to be your ground. If you can see that.
Plus 12 on the end and ground in the middle.
So what we've done, we're going to take it just like this. Again, you can see that the end there, the business end, is on that side. I'm going to flip it over and insert it in our breadboard just like this. And I find it convenient. You can see that I've lined it up here on the edge so that it's more or less flush.
Nice.
What that allows me to do, and I'll demonstrate this just once, this will be consistent for the rest of the semester. It gives what it does is it puts the 2 leads that are actually going to be active against these ones in the middle. And you can see that they're in line with the 2 wires that I've already set. Oops, sorry.
A little bit off.
Can't see it.
Yeah.
There you go. I've put them in line with the 2 wires that I've already set. And from this breadboard, we know that these going across the way here are all connected, and on the edge, these going this direction are connected. So what we're going to do is we're going to pop this back in so that this line corresponds with the positive, and this orange one on mine, again, you might be a different color, that corresponds with the ground.
And the middle pin, the one sticking out here, isn't connected to anything. Oops.
That little piece of silver
that
you can see.
Yeah, this little piece right there is just left floating. So just leave that one alone.
You won't get anything out of that.
Yeah.
So, all right.
And by doing that, what happens now is the plus 12 that's coming in here on the yellow wire jumps across to this column and travels all the way down here, and then we can grab it back to another row of the breadboard and access it on this line there. My finger is much too fat. That screwdriver would be really handy for this. Yeah, really good pointer there. So any component that we connect in these other 4 holes in this 5-hole row here will have plus 12 volts on it. And then we can connect it down to some other component, another component, And then on this row here, we're going to have our ground, which is returning a connection all the way back up this pathway here to the other orange wire, back to the ground on the power supply, and forming a complete circuit.
So again, feel free to pause the video if you need to just sort of get the basic layout here. So again, we've already preset a couple wires, and you go ahead and do that. This is going to correspond. They don't have to be exactly the number of holes away or whatever. I just set these sort of arbitrarily, just give us a little space to work with. We're going to try. Now we're going to pull out some resistors. So let's see. Maybe I can zoom out a little bit. In your bin, we're going to look for the resistor that corresponds. Now I've already pulled it out of the little tape here. The resistor that corresponds with, I believe we have a 220. That's the red, brown. The 470 is the yellow, purple. So just like in our lab, and feel free to manipulate these wires on the resistors. We need to bend these gently. We don't want to break them. But we need to bend these into a configuration that we can actually insert them into the breadboard. So, I believe our circuit on our lab has the 220, this is the red, brown, connected to the positive 12. So again, I'm going to put one lead. Sorry if that's a little unclear. One lead goes into the positive 12. And then another lead goes into a spot a little ways down. Let me zoom in again so we get a clear picture of what's going on. Sometimes these wires get a little bit shadowed. It's difficult to see, but I'll tilt it for you.
Nice.
So you can see that one lead is going into the row with the yellow wire that's connected to it. And the other one doesn't have anything connected to it yet.
And you want to make sure that the wire goes all the way through. There's a little clip that's going to grab onto it. Sometimes people just kind of place it on the top there. It really has to slide into the board. And there's another trick I'd like to show real fast. So for the second resistor, sometimes people, when they try to plug these in, they put their fingers like way up high, right? And when you push down, it sort of bends the wire like that, right? And it gets really frustrating because then the wires get all mangled. So the trick to that is to actually hold the wire really close to the base of the board. You know, like you want to slide your fingers down pretty far, and you want to get a good grip. It's kind of slippery. But by pressing close, I don't know if that was clear, but pressing close to where the wire's going in there, you'll definitely feel it slide in, and it won't be liable to bend as much. Although I put it in the wrong place.
I'll fix that for you. So in this case, we want to actually put this lead into where we have the orange wire.
There we go.
And I've slid it in all the way.
Nice.
Again,
once they get bent, they can be a little more challenging to plug in. So.
That's true. You'll figure out the best way to do this on your own.
Yeah, it's definitely a tactile sort of thing.
Yeah, it's hard to show that on a video. So in this other side, just so it's clear, goes into the same row as the first resistor that we put in. So you can see these are now lined up in the middle.
And they're connected electrically now because they're in the same row.
Exactly right. Okay, so there's our circuit and there's our setup.
Great.
So now that we have the setup for our breadboard, we've created this little small circuit. We've connected our wires and our resistors. We are missing something though, and that's the power. So here's the other end of our power supply. Again, you should have two. I've plugged one into the wall. I won't show you that, but anyway, that's the other end. So this is actually plugged in already. Now, it's always a good idea to check your circuit and maybe double check it before you plug any power in to make sure that you have the right leads connected, you have the right orientation. Obviously resistors in this case, they don't have an orientation, but we do want to make sure that we have the plus connected to where we want the plus and the neutral connected to where we want the neutral. So I've gone ahead and checked this circuit. What we're going to do, and remember, there's no switch on this. This is live. As soon as you put it in, you're going to get 12 volts through your circuit. So Here we go. So our task first is to measure voltage, and that's why we have our voltmeter out here. I'm going to select our DC voltage. That's this little red thing up here. I already have these little probes, that's what they're called. I have these connected already. Red and black, so red is going to be our positive, black's our neutral. And as the step in our lab states, what we want to do is check our voltage across each resistor in turn. And remember, these wires coming out of each resistor, if you could see those, it's probably a little bit difficult to see just exactly what I'm doing here. Maybe if this is a little bit clearer. This might be a little bit challenging for me. I'm going to put my two leads right on either side of this resistor. And I want you to notice what the voltmeter is doing. Just as an aside, you'll notice that the voltmeter, when it doesn't have anything connected to it, you can see my leads are not connected to anything. It does sometimes bounce around a little bit. You'll see that there's a little millivolts there. It's picking up some either inductance in the air or some little internal circuitry voltage measuring going on. Don't worry about that. It doesn't mean that your meter is necessarily broken. Generally, when you connect it to the circuit, it will stabilize. So again, I'm going to connect two sides of this resistor, and you'll see that it settles down. And that's that number. Just want to point out one other thing. Right now, I just have these simple probes connected. In your kit, you'll notice that you do have these other cables. You'll have a red, black, and a yellow. Conveniently, the red and black are the same colors. And I'm actually going to switch these over just so I can illustrate this a little bit better. The side of your cables here that don't have the extra insulation, these are called the banana, they can actually slip right into the same holes on your voltmeter as those other probes, and conveniently on the other end of these is an alligator clip. So now instead of just kind of poking and prodding around, we can actually take our clips and clip them to each side of the components we want to measure. And that way it's a little more stable, you don't have to hold on to it the same way, and you can see that obviously it works the same way. Now for the other resistor, again, we're going with the positive because on our configuration we have our positive terminal connected to the outside of the breadboard, and then that jumps over to this one. The current is going to be flowing through this first resistor and then the second resistor. So we're going to put the positive side on this lead of this resistor, the neutral on that side, and we're going to get a number. We're going to reading on our voltmeter. Again, this is all part of the lab, and that is how you measure voltage. Now notice I didn't take any components out. They're still connected. You can see that the wiring is still part of the breadboard. For the next part, measuring amperage, measuring current, we have to just deconstruct this a little bit. But for now, that is measuring voltage. So for this part of the lab, we're going to be measuring current, which is a slightly different process than measuring voltage. In fact, it's very important to carefully follow the instructions for your own safety, and also because these meters will, in fact, they have a fuse in them, and you will blow it if you don't do this correctly. You can also overheat your components. I suppose in a rare case, you might even start a fire. So it's important to understand how these work and to do this correctly. Now you'll notice I've modified the circuit, just as in your lab. Before we just had the two resistors, I've added a third resistor right here. That's the 1K ohm Just as a side note, in terms of safety and just good practice, I've also disconnected our power. So whenever we're modifying our circuit, it's always a good idea to disconnect the power, again, for your safety and for the components as well. Now you'll notice that for our setup, and let me zoom in here, what we've done is added this resistor, and we've done it in parallel. This is our 1K, the smaller one is our 1K ohm resistor. This one was the one we started with before when we were measuring voltage, and that's the 470 ohm. And you can see that I've put it in its own holes on the breadboard, but it's in line with the other resistor. So in this case, now we have two resistors connected on one end, and that goes to our neutral lead on our breadboard. Remember, the inside is our neutral and the outside is our plus 12 volts, also known as ground, the neutral. All three resistors are connected in this middle row. You can see that very clearly. And then obviously we didn't touch this resistor, and that goes into our plus 12. So now for measuring current, let's see if I can get all of these components in the view for you there. What I'm going to do is, instead of when we measured our voltage, we just connected the leads up to the resistor and we got our voltage. This time we have to do a couple different things. First of all, we have to select the correct setting on our multimeter. So we did have DC voltage here earlier. Now we're going to use DC milliamps. It's this blue one here on the left. So we're going to turn our dial all the way to the setting where it says DC and a small m, capital A. That stands for milliamps. I'll try to get the glare off of that so you can see that it says DCMA, and that's what I've selected. You'll notice it doesn't read anything yet. I haven't connected it. Now for this, I think I already explained, we have to break this circuit. Now in order to do that, we have to actually pull out one of the components. So the first thing we're going to measure is the current that's flowing from the positive 12, the plus 12, and into this end of the first resistor, the 220 ohm resistor. In order to do that, I actually have to physically pull this wire out. Let's see if I can show that to you. You'll see that I've actually pulled this side of the resistor out of its breadboard. Let's see, we'll try not to mix these up too much. And what I can do is actually attach the neutral, the ground end of my multimeter rather, to that side of the resistor. Now in order to connect the positive side, I'm actually just going to take a wire out of my little wire kit, and I'm going to put it, you could do this in a number of different ways, because this is all going to be the same plus 12. You could in fact put it on this side, you could put it where you had your resistor before. In this case, I'm just going to put it here, anywhere along this outside row, because remember this is going to be plus 12. And this is going to be where I connect the positive side of my multimeter. Now you'll notice it still says 0. It's because I haven't connected the power yet. But I just want to double check the circuit. So again, here's the positive side, goes to my positive input of my multimeter. That of course enters, the current enters the multimeter on this side, goes through the circuitry of this as it's measuring it, comes back out, and this is the current, comes back out of the neutral side, or the ground side, and then, or at least in this case, the black wire, goes back into this resistor and then through the rest of the circuit. So what I'll do now, I've checked my circuit again, going to carefully plug in. And again, you'll notice that we have this in milliamps, so just be aware of that, what you're measuring. You can see that on the multimeter, it says MA, milliamps. 22.8, so there you go. There's the current flowing from this part of our circuit through the rest. Now, in order to measure other parts of this circuit, again, I'm going to have to end up changing the circuit a little bit. I'm going to disconnect the power first, and this obviously should go back to 0. In order to measure other parts of the circuit, you have to break that part and put the multimeter in series with that part of the circuit. In order to do that, what I'm going to do is reconnect the circuit part that I just broke, and that's this first resistor. So I'm just going to put that resistor back in. And let's say I wanted to check the current coming from a different spot. Perhaps I want to check the current between this resistor here and these two on this common part here. I'd have to actually disconnect all 3 of these. So there's one lead there. And maybe a convenient way to do this, I'll take my little probe here with the wire attached to it. I'm going to take it out of this spot and connect it to those others where I had this resistor lead connected before, except that, remember, I'm going to want to change my polarity here because this is where the positive current is going to be. Here's the neutral. So there's just an example. Let me zoom in on this so you can see it. If we wanted to measure the current between this resistor and these two here on this part of the circuit. Just to follow the current, it's a good little check. The current's going to be coming in through this lead of the resistor and out this side. Here's my positive of my multimeter. Obviously goes back into the multimeter, comes back out on this side, and the current continues to flow through this little brown wire that I have here. You can use any wire you want. And it goes back through these resistors that are in parallel and back through this orange wire and back into my neutral or the ground part of my circuit. So I'll just demonstrate this really quickly, and you can, on your own, do the rest of the circuit in the same fashion. And again, I haven't connected the power yet, which is why there's no current flowing. As I do that, you'll see that in this case the current should be the same. And again, when you're done, especially if you're just measuring voltage, you don't necessarily have to pull the power out each time. But in our case, we have to actually rearrange our circuit. So it's a good idea to just make sure the power is disconnected, your 12 volts. So again, in order to test a different part of the circuit, I'm just going to deconstruct this part. Put this resistor back in. So now it's our original circuit. In order to measure a different part of the circuit, again, you'd have to disconnect whatever section you're looking at measuring, and then connect the probes in series with that part of the circuit. And that's how you measure amperage. Again, just be careful. If you don't disconnect the part and put this in parallel like you did for measuring voltage, you do have the chance of blowing the fuse in the voltmeter, and that's kind of a pain to change. So there you go. That's measuring amperage. So that should do it for this lab. The introductory lab 1 for setting up your circuits, understanding the breadboard, learning how to measure voltage and current. If you have any questions, of course, you can always consult the lab. You can ask Tom. You can contact him. He answers questions pretty frequently and thoroughly. And otherwise, I hope you enjoyed this, and we'll see you next time.